Compounds. They are the building blocks of everything around us. Hey there, science fans. Welcome to another exciting journey into the world of science. Today, we're diving into the fascinating world of compounds. Compounds are everywhere around us, and they play a crucial role in our daily lives. Imagine the universe as a giant Lego set. Just like how you can build amazing structures with Lego blocks, the universe builds everything with tiny building blocks called atoms. Everything around us, from the air we breathe to the food we eat, is built from these tiny building blocks. Atoms are the fundamental units of matter, and they come together in various ways to form different substances. Now, sometimes these atoms like to hang out solo, and that's cool. These are called elements, and they are the simplest forms of matter. But more often than not, they prefer to team up and form something entirely new: compounds. When atoms of different elements join together, they create compounds with unique properties. A compound is formed when two or more different types of atoms join together in a fixed ratio. This means that the atoms combine in specific proportions to create a new substance. This fixed ratio is super important. It's like a recipe. You can't just throw ingredients together randomly. You need the right amounts for it to work. For example, water is a compound made of 2 hydrogen atoms and 1 oxygen atom. Just like in cooking, where you need the right measurements to make a delicious dish, in chemistry, you need the right proportions of atoms to create a stable compound. If you change the ratio, you get a completely different substance. So get ready to explore the amazing world of compounds with me. We'll discover how these combinations of atoms create the diverse materials and substances that make up our world. It's going to be an electrifying ride. From the simplest compounds to the most complex, there's so much to learn and explore. Let's dive in and uncover the secrets of compounds together. We've talked about compounds, but what about elements? Think of elements like the individual ingredients in our Lego set. Each element, like hydrogen, oxygen, or carbon, is made up of only one type of atom. When these elements combine, they form compounds with completely different properties than their individual components. Take water, for example. It's made from 2 flammable gases, hydrogen and oxygen. But when they combine in the right ratio, 2:1, they create water, which is not flammable at all. This drastic change in properties is what makes compounds so interesting. It's like mixing flour, sugar, and eggs. Individually, they're pretty basic, but combine them, and you get a delicious cake. Now that we know how compounds are formed, let's zoom in on the tiniest units of these amazing structures: molecules and formula units. These minuscule entities are the building blocks of everything around us, from the air we breathe to the water we drink. A molecule is the smallest unit of a covalent compound that still retains the properties of that compound. This means that even if you break down a covalent compound to its smallest molecule, it will still behave like the original substance. Think of water again. A single water molecule, H2O, is made up of 2 hydrogen atoms and 1 oxygen atom bonded together. This simple yet elegant structure is what gives water its unique properties, such as its ability to dissolve many substances and its high surface tension. This tiny structure is responsible for all the amazing properties of water. From the way it forms droplets to its role in sustaining life, the water molecule is a marvel of nature. Formula units are similar but apply to ionic compounds. Unlike molecules, which are formed by covalent bonds, ionic compounds are held together by ionic bonds, which are the electrostatic forces between positively and negatively charged ions. They represent the smallest ratio of ions in an ionic compound. This ratio is crucial because it determines the compound's overall properties, such as its melting point, solubility, and electrical conductivity. For example, table salt, NaCl, has a formula unit of 1 sodium ion and 1 chloride ion. This simple ratio is what makes salt so effective at preserving food and enhancing flavors. Understanding molecules and formula units helps us grasp the fundamental building blocks of matter and how they interact to create the world around us. By studying these tiny particles, scientists can develop new materials, medicines, and technologies that improve our lives in countless ways. So the next time you look at a glass of water or sprinkle salt on your food, remember the incredible science at play in these tiny particles. Enjoying the video so far? Subscribe so that you ace that chemistry class. Or if you like learning about chemistry for fun, Regardless of why you clicked on this video, subscribe so you never miss any future ones. Let's get back to the lecture. Remember how we talked about atoms liking to team up? Well, they do this by forming chemical bonds, and one way they bond is through covalent bonds. Imagine two atoms holding hands. That's kind of what a covalent bond is like. In a covalent bond, atoms share electrons with each other. It's like sharing your video games with a friend. This sharing helps both atoms achieve a more stable state, just like having a friend to play a game makes it more fun. Covalent bonds are essential for life. They hold together the atoms in our DNA, proteins, and carbohydrates, basically all the important stuff. Covalent compounds, from water to diamonds. Covalent compounds are a fascinating and integral part of chemistry, forming the backbone of many substances we encounter daily. Covalent bonds form some of the most diverse and essential compounds, known as covalent compounds. These bonds occur when atoms share electrons, creating a strong connection that holds the atoms together. These compounds can be as simple as water, which is essential for all known forms of life. Water's unique properties, such as its high specific heat and surface tension, are due to the hydrogen bonds between its molecules, or as complex as DNA, the molecule that carries the genetic instructions for life. DNA's double helix structure is a marvel of molecular engineering, with covalent bonds forming the backbone of the molecule. One type of covalent compound is called a molecular covalent compound. These compounds, like water, are made up of individual molecules held together by covalent bonds. Carbon dioxide, another molecular covalent compound, is a gas at room temperature and plays a crucial role in the Earth's carbon cycle. Sugar, a solid molecular covalent compound, is vital for energy storage in living organisms. These molecular covalent compounds tend to have lower melting and boiling points compared to ionic compounds, which is why substances like water and sugar melt and boil at relatively low temperatures. Another type is called a network covalent compound. These compounds form a continuous network of covalent bonds, creating a structure that extends throughout the material. These are like giant interconnected networks of atoms held together by a continuous network of covalent bonds. Think of diamonds or quartz. Diamonds made entirely of carbon atoms are renowned for their hardness and brilliance. They are incredibly strong and have very high melting points. Network covalent compounds like diamonds and quartz are used in a variety of applications, from cutting tools to electronic components, due to their strength and durability. Covalent compounds are everywhere, from the air we breathe, which contains molecular covalent compounds like oxygen and nitrogen, to the gasoline that powers our cars, a complex mixture of hydrocarbons that are also covalent compounds. They are a testament to the incredible diversity and power of covalent bonding. The study of these compounds not only helps us understand the world around us, but also drives innovation in fields ranging from medicine to materials science. Ionic bonds opposites attract, forming strong bonds. Now let's talk about another type of chemical bond, ionic bonds. Remember how opposites attract? That's the basic idea behind ionic bonds. They form when one atom gives up an electron, becoming positively charged, while another atom accepts that electron, becoming negatively charged. These oppositely charged ions are then attracted to each other, just like magnets. This strong attraction forms the ionic bond, creating a stable compound. Table salt, or NaCl, is a classic example of an ionic compound. Ionic bonds are responsible for the existence of many essential compounds, including salts, minerals, and even some components of our bones and teeth. Ionic compounds, salt, minerals, and more. Ionic bonds create a fascinating class of compounds called, you guessed it, ionic compounds. These compounds are formed by the electrostatic attraction between positively and negatively charged ions. They usually have high melting and boiling points because of the strong forces holding the ions together. Think about how much heat it takes to melt salt. Ionic compounds are often found in nature as minerals like quartz and feldspar. They are also used in many everyday applications, from fertilizers and detergents to batteries and medicines. Molecular versus empirical formulas, chemical shorthand. Chemists love shorthand, and that's where molecular and empirical formulas come in. These formulas are like nicknames for compounds, telling us the types and ratios of atoms present. The molecular formula tells us the exact number of each type of atom in a molecule. For example, the molecular formula for glucose is C6H12O6, meaning it has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. The empirical formula, on the other hand, shows the simplest whole number ratio of atoms in a compound. For glucose, the empirical formula is CH2O. It tells us the relative proportions of atoms, but not the actual number. Both formulas are useful tools for understanding and representing chemical compounds. Unlocking the secrets of chemistry, compounds, and beyond. Congratulations, science explorers! You've journeyed into the world of compounds, exploring their formation, types, and importance. From the water we drink to the air we breathe, compounds are everywhere, shaping the world around us. Understanding compounds is like having a secret decoder ring for the universe. It allows us to understand how matter interacts, creates new substances, and ultimately forms the building blocks of life itself. So keep asking questions, keep exploring, and keep that scientific curiosity burning bright. The world of chemistry is vast and full of wonder, waiting for you to unlock its secrets. Make sure to subscribe and like this video and share with a friend if you thought it was useful. Be sure to have a nice night, and good night!